Hello, we're back. So we left off talking about the complement and the formula for the complement, okay? Example 2. In a standard deck of playing cards, we have 52 cards in 4 suits: clubs, hearts, diamonds, and spades. Each suit has 13 cards, 9 numbered cards, 2 through 10, an ace, a jack, a king, and a queen. Complete the chart based on the above information. Okay, so in every situation, we are drawing from 52 cards. Okay, that's really important because that is our total number of outcomes. Not just the outcomes we want, but even the number of outcomes that we don't want, okay? That number is going to show up in our denominator. All right, so we've got the event and the event space. So the event is drawing a king of hearts. So that makes us happy. It's what we desire, okay? So specifically, the event space is listing all the things that will make us happy, what we desire. So a king of hearts, okay? The theoretical probability of getting a king of hearts is the number of events in the event space, so that's 1, over the total number of outcomes, which we've already said is 52. Okay? So is it a simple event? Yes, it is. Since the 1 is in the numerator, so since 1 is equal to the numerator, therefore it is a simple event. When it becomes not simple, it becomes more complicated, okay? Drawing a numbered diamond. So what does that specifically mean? Numbered would be anywhere from 2 up to 10, but it would have to be a diamond. So that could be anything like a 2 of diamonds, a 3 of diamonds, a 4 of diamonds, a 5 of diamonds, a 6 of diamonds, a 7 of diamonds, an 8 of diamonds, a 9 of diamonds, a 10 of diamonds. Okay? So the theoretical probability then would be counting the number of desired outcomes in our event space. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting a numbered diamond is equal to, I think I counted 9. 4, 9, 9 out of 52. Okay? Since the numerator is not equal to 1, therefore it's not a simple event. C. Drawing an ace, a jack, a queen, or a king. That would make us happy. Now there's lots of specific aces. In fact, there are 4 aces that would satisfy our requirement, and 4 jacks, and 4 kings, and 4 queens. So in our sample space, we've got also 52, but in our event space, we've got the clubs, okay? So we've got an ace of clubs, we've got an ace of hearts, we've got an ace of diamonds, and we've got an ace of spades. Okay? Now, I don't play cards. I think I mentioned that at Google Meet, but I do give you the handout with information about the deck of cards and what it contains so that you're not lost, all right? So that would be the ace. So there were 4 aces that would make us happy. We'd also be happy with a jack because our event is always what we're hoping to get, okay? So a jack, continuation, so we could have a jack of clubs, a jack of hearts, a jack of diamonds, and a jack of spades. Okay, and then a king, we'd have a king of clubs, a king of hearts, a king of diamonds, and a king of spades. And then for the queen, we'd have a queen of clubs, a queen of hearts, a queen of diamonds, and we'd have a queen of spades. All right, so the probability is what or how many is the proper phrase. How many of these events are there? That's the numerator. So the probability of drawing an ace, a jack, a king, or a queen is equal to how many here? Well, there's 4, and each row is groups of 4. So there's 4 times 4, so there's 16. I can count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Out of 52. I could divide that then by, what, 4? Okay, and I would get 4 out of 13, right? So probability would be 4 out of 13. So I look at the numerator. Since the numerator equals 16, you want to look at the original numerator. Therefore, it isn't a simple event. Okay? What about not drawing? So notice, not drawing an ace, a jack, a king, or a queen is the opposite. Right? They're opposites. So if I could think of the sample space where I have my 52 cards, okay, and my jack, my queen, my king, and my ace are in here, everything else is not the jack, the queen, the king, the ace, right? So not means you have to subtract from 1, right? So that would be, and we could do this in the long way, which we will do. So if it's not any of these cards, it's definitely, though, the 2 of clubs, the 3 of clubs, all the way up to the 10 of clubs. It's the 2 of hearts. It's the 3 of hearts, all the way up to the 10 of hearts. It's the 2 of diamonds. It's the 3 of diamonds. It's all the way up to the 10 of diamonds. And it's the 2 of spades. It's the 3 of spades, all the way up to the 10 of spades. Always make sure you're trying to do your 3 dots, okay? It's 3 dots you use. Okay, so there is, if you count all of these, including the ones that aren't written, you would have 9 more, 9 after that, 4 groups of 9. So 4 groups of 9 are 36. So you could say the probability of not an ace, a jack, a king, or a queen. Okay, so not these is 9 times 4 is 36 out of 52. Or you could say that you want the complement. Actually, we'll put the symbol at the end of the bracket. So if you want the probability of a ace, jack, queen, king, that's not that, right? It's 1 minus the probability of a ace, jack, king, queen. Okay, so that would be 1 minus what we had up here, 16 over 52. So 1 becomes 52 over 52. Okay, and that becomes 36 over 52, right? You subtract it, you have 36 over 52. Then you'd want to divide by a common denominator. So that would look like 4. So that would be 9 over 13, right? So since the numerator, always start with the original, okay, without reducing. So since the numerator is equal to 36, or not, let's be consistent, not 1. It does not equal 1. Therefore, it's not a simple event. Okay, please make sure that you try this work and upload it to assignments.